In any situation where you can use a Venn diagram, you can use a two-way table, and two-way tables show a lot more information. Everybody good? Have you guys heard of a Venn diagram before?
Yeah.
So it's like you always start with like a boundary box, and it has two sometimes overlapping circles, usually overlapping, but not always. Okay? And so I'm going to label one of these with a P and one of them with an M. Are we all comfortable with that basic premise? And that P is the pets group. The M is people who use the mullet-style toilet paper. Okay? So one of those circles represents one of your variables. One of those circles represents the other of your variables. Okay? Now, this section in the middle, what would this represent? People who have pets and use that mullet style of toilet paper. Everybody good? Yeah. Okay. And how many people is that? 8. So those 8 people go in the middle. All right, next. What does this section represent?
Total number of people who have pets.
Sorry, thank you for playing. Because to be in this section, you have a pet, but you don't use the mullet-style toilet paper. Because it's outside the M circle. So this should, in fact, be 33. And you want to know why I hate Venn diagrams? Because everybody puts in 41 there. And the way I see the 41 is how many people are in this circle total. You guys with me?
Mm-hmm. So then would it be 3 for mullet?
3 for inside mullet, outside pet, right? So like that's how you got to start thinking about it. Where is it in relation to both circles? Okay, and then hold on, we're missing something. Nope. We haven't accounted for everybody here. I know that because my total is 56, and those numbers don't add to 56. Who haven't we included yet? No pet and beard. Mm-hmm. Those 12 people go out on the outside.
So could you, if you were asked to create a Venn diagram, could you pick whichever, variables you want to represent?
Well, so you wouldn't want to do, P and P complement.
Yeah.
But you could have done P and B.
Yeah. Okay.
But then that would just make me hungry. Because I love peanut butter. It's the best. Now, I also hate Venn diagrams for probability, right? Because if I said, given that somebody has a pet, what's the probability that they also use the mullet-style toilet paper? And you know what everybody is going to say? 8 out of 33 instead of 8 out of 41. So I really do hate them.
Yeah. Is there any, positives to, is there any reason you would use it over a...
Let's hold on to that, but yes. Okay. Now, if I ask you guys to find the probability of somebody using a mullet, you would say?
8 over 41. Oh, wait, is that just a... Oh, 11. P given M.
No, just finding the probability of getting a mullet, yes? Or using the mullet approach.
Yeah. 11. What is the letter in the middle? It's just, it looks like an L, but it's actually a parenthesis.
It's just a parenthesis, man. Are we guys...
I was confused. I thought it was an L also.
You guys are so critical of me. Jerks.
Well, now what is it? It's way longer than the rest of them. Nico, I think you might die today.
0.19-ish. Somebody help me out. I think it's 0.19. Might be 0.196. Might round up to 0.2 still, I don't know. 0.196?
Mm-hmm.
All right. What is the probability I pick a person who has a pet and uses the mullet approach? Be 8 out of
41.
56. We don't know that the person has a pet. When we do an and, we're saying what's the probability of something, right? And it's pet and mullet, right? And so we don't know they have a pet. That's a different chance event. Do they have a pet or not? And then do they use the mullet toilet paper? 0.143. Very good. Now, here's this part's new. Okay. What is the probability that somebody uses the mullet approach or has a pet? Okay. Anybody have any thoughts?
I remember Ben brought up a question last week about it, and you were like relating to it. It was something with like addition, you know?
We're doing the addition rule today, for sure. Okay, so here's what we're gonna do. The probability somebody has a mullet is 11 out of 56, yes? And essentially what I did is I added in the mullet row. 11 out of 56 to get that probability of a mullet, yes? What's the probability of having a pet? It would be 41 out of 56, yeah? And that is this row, or this column, yeah? There's something wrong with what we've just done. Can anybody tell me what that is?
Used 8 twice.
I used these 8 people where they intersect here. They were counted in both totals, but do they exist twice? No. So what the addition rule says is that to find an or probability, you add together the two probabilities, but then you have to subtract away the overlap.
So is that the benefit of the Venn diagram?
The benefit of the Venn diagram is you can kind of see, hey, if those were my 41. You can see my 41 here and my 11 here. You can see that 8 is counted twice. 44 out of 56, which I'm going to guess is like 0.78, 0.79, something like that.
0.786.
Now, that addition rule, that or probability formula, is also on your formula sheet. Cool?
Will this be the test we get our formula sheet?
Either we'll see, because I usually laminate them, and getting them cut out and stuff during play week is probably unlikely, but you will probably get the formulas on the test.
Oh, yeah.
Like you'll have the equivalent of your formula sheet, if that's cool. Everybody good? All right. Ooh, what a good opportunity for us to make practice. So let's go ahead and make a two-way table of this particular case. So when we're creating our own two-way table from some sort of descriptor, the first thing we want to do is analyze what a two-way table, that 2 stands for 2 different variables, yes? In this particular context, what are those 2 variables?
Whether or not you read the newspapers.
Each newspaper, right? So I'm going to call this one USA Today and this one USA Today Complement. So one is that they read USA Today, the other is that they don't. Does that make sense? And that one variable goes across one of my 2 axes. If I put that on the up and down axis, it would not change anything. I mean, it would be fine. There's no reason that one has to be on top versus the side. Okay, and likewise, I'm going to call this one New York Times, and then New York Times complement.
So is the compliment, so is USA compliment, is that New York Times or is that just they don't read USA?
That they don't read USA Today. All right, now, tell me some things we know.
35% of readers read USA Today.
This is 35%. And guys, if 35% read USA Today, what else do we know?
That's 65.
65 don't. And that we have a total of 100%.
And then 15% read New York Times.
15% read New York Times, leaving 85% who don't.
And 5%.
5% read both. And from here, can we fill in the rest of the two-way table?
What is the five? Yeah.
Oh,
Sorry,
it's
wait,
fine.
get the 5% who don't again?
The 5% who read both.
Okay.
It's just that the percent was written out instead of... It's like one of the sneaky things that happen. Do we feel good so far? And then knowing this, can we fill in the rest of the table? Yeah. This would have to be 30. This would have to be 10. This would have to be 55. And I love placing the last thing. It's like doing a Sudoku puzzle. Hey, look, it matches all the way around. All right. So, have fun, guys. You guys are doing the Venn diagram for this.
Is the Venn diagram recognized as like a helpful form of looking at it by like people?
I hate Venn diagrams. I don't think they're useful at all.
They don't seem very useful.
They help us with OR probabilities. It's a little bit easier to see why we subtract that overlap.
Have you guys been watching interviews? What's it about?
Okay, so can somebody tell me what is the probability? How do we put this question into symbols? Find the probability the person reads at least one of the two papers.
It would be like N or U. N or D or U.
It would be an or question, which means we're going to do the probability that they read the New York Times is 15%. Plus the probability that they read USA Today is 35%. Minus the overlap, the 5% that read both. And we should end up with 45%. All right. What if I say find the probability that a person doesn't read either newspaper? What would that be in siblings? Or in symbols? I don't know why I said siblings. What would it be?
The complement of each one.
New York Times complement, USA Today complement, and then we have to, and it's an and, because it would mean that both of those things have to be true. What's that answer? 55%.
Oh, yeah.
And does it make sense, you guys, that these two are actually complementary of each other?
Yes.
Okay? Like, if I wanted to highlight on the two-way table, here's my or probability. Those are all the people that read one or the other, leaving this one to be the intersection of their complements. Very good? All right, from here, all I ask is that you work on statistics in some way, okay? And because this is statistics class, right? So you have 20 minutes to work on, to do some practicing stuff. Is everybody with me? And so you can either do the review that I passed out on Friday. That review is very much what your quiz is going to look like tomorrow. There was an issue with the answer key that I posted on Friday. I have since fixed it. So particularly on the first page, problem number 2, there was an issue. Because I did greater than 2, but it said at least 2, which would be greater than or equal to 2.
Yes.
Okay.
I thought I was goofing.
If you've got that review done correct, or if you're all good, then you can do stuff on AP Classroom. We'll do some more on AP Classroom tomorrow and Thursday. Okay? So we all get it's a reasonable request that you work on some version of statistics questions.
In statistics class?
In statistics class, yes. I try to be reasonable.